this question is pretty straightforward. We've been given the positive lengths of the sticks. We have to pick sticks in a way that their sum is going to be the sum of their lengths is going to be the cost of connecting them, and then whatever the cost is of combining them together, you add it back to the array, and then you keep doing that until unless there's only one stick left. But what you have to do here is that you have to find the minimum cost of doing so. So as the example has been given, if you pick stick 2 and 3 first, then the cost is going to be 5. You add it back to the array. The only stick that is left is 4. Then you pick 5 and 4, and then the cost is going to be 9. You add it back to the array. There's only one element left. There's only one stick left in the array, and the cost comes out to be 9 plus 5. So if we look at another example, this is another example that I've taken. The best answer that you're going to get is if you pick 1 and 2 first, add it, and then you add the cost back to the array. Then you pick 3 and 3. After picking 1 and 2, the elements that we're going to be left with 3 and 3, and then 5 and 4 and 6. Then you want to pick out 3 and 3, which would give us 6. We add it back, 5, 4 and 6. Then you want to pick out 4 and 5, which will give us 9, and then we have 6, and we have 6. Then we want to pick out 6 and 6, which will give us 12, so we add it back. And then we want to pick out 9 and 12, which will give us 21. And then when you add the sum of all the costs, that is what the answer is going to be. So if you notice here, we are every time trying to pick out elements that are the least. One way to solve this is that you sort it, then you pick the elements, you add the sum back to the array, then you sort it again. Whatever the answer was, you add it back, sort it again. So you'll have to sort it every time. That is one way of doing it. And the other way of doing it is, if you notice, if we are trying to pick out just the minimum elements, we can just use the min heap, right? That way it'll always give out the minimum element from the elements that are present in the heap. So that is clear. We're going to use a heap, and it is going to be a min heap. So let's just start coding. We will have the initial cost, which is going to be set to 0. This is the cost that we're going to return, because we're going to have to keep a track of what was the cost, right? When we added 1 and 2, the cost was 3, so the cost has to be added somewhere. That gave out 3, then this gave out 6 when we added these are the costs, right? So we have to keep adding them. So this is the variable that we're going to use for that. Then we create a priority queue of integer. We want this to be a min heap, so the creation is going to be straightforward. Then let's just handle some corner cases, or we can handle it at the end. Let's just start adding the sticks to the heap. So you get a stick out of the sticks, and you just add it to your priority queue. So at this point, the queue is ready, right? Now you can just start processing it. So we are going to have to pull out 2 elements out of the priority queue every time to add them, because we're picking 1 and 2, and then we're adding it and then pushing it back. So first check that we want to do is that the length is greater than 1, so that there's at least 2 elements present in it. So while the size of the priority queue is greater than 1, so this means that at least 2 elements are present. We want to continue doing this, so we will get the length of first stick, just pulling the item out of it, and stick 2, get it out of it. Now we have 2 sticks, which in the beginning is going to be 1 and 2. The cost is going to be stick 1 plus stick 2, and I'm adding it to the existing cost because we have to keep a track of. So the initial cost was 3, then we want to add 6 to it, then we want to add 9 to it, and 12. So we're going to keep adding it. And then what do we want to push to the queue again? The sum of these, right? The cost. When you added 1 and 2, you pushed 3 back to the heap because we want it to be sorted again. When we added 3 and 3, it gave us 6. But we don't want 6 to be picked first. We want 5 and 4 to be picked first. So we want to add their sum, their cost, back to the queue. Now when we're done with this, we can just return the cost because this will ensure, since you're only going to the priority queue if there are at least 2 elements, and then you're adding their sum back to the queue. So there's always going to be at least 1 element in the queue, but there's going to be some corner cases, of course, if there's only 1 element or less than 1 element, right? So this wouldn't hit at all, and we don't handling that is not that tricky. So if the size of the stick, the length, it's an array, so the length, if this is smaller than 1, then you just return 0. Smaller than equal to 1, then you just return 0. You don't even go there. So now let's look at the examples. If we add our custom example to it, and this should just work.